we'll get started. Okay. So let me pull up my note and get some notebook lines on it. And then I'll share it with you. Okay, so you should see my notebook paper now. And we're going to start with a picture, kind of explaining visually what we're doing today. So let's say we've got a function, and I'm just going to draw in some random function here. And it looks like this. You guys, if this function is somehow modeling a real situation, like it's modeling a cost or a revenue or something like that, obviously there are parts of this graph that aren't going to make sense in the context of the problem. So when we're doing these applications, like I said, they're going to be restricted. They're going to give us a function and say, hey, but you can really only look at a certain interval of the function. So I'm going to create an interval on this function. Let's say that this function only makes sense in context for us from x equals a to b. So at x equals a, we're at a point here. At x equals b, we're at a point here. Now, as I mentioned, the first kind of interval we're going to look at is a closed interval. So when you're reading one of these problems, that a and b, first of all, they'll actually be numbers, but it'll say from a to b with the brackets. So just remember that if you're in interval notation, the brackets mean that your interval is closed. So to be closed, it means that both a and b are included in your interval. So I can look at any value between a and b, but I can also look at a and b as points. So we are on a closed interval from a to b. Now, anytime you restrict your function to an interval, the max and the min in that interval have a lot more weight. Because let's remember what you've been finding in 12.1 and 12.2. You've been finding max and mins, definitely. You found these critical points, and we classified. We said, oh, this one's a maximum or this one's a minimum. But you guys, those were what we call relative max and min, or local max and min. This is a maximum point relative to the points around it. The same with the minimum. It's relative to the points around it. It's not, this right here is not the absolute max value of the function. Why not? Well, because this function goes up forever. And if you think you found the absolute highest point on this function, you could still find one higher, right? It always keeps going higher. And the same with this minimum, you guys. It's a minimum relative to the points around it, but it's not what we would call the absolute minimum value of the function, because this function goes down forever over here. So you guys, if you think you're at the lowest point, oh yeah, this is the lowest point of the function. No, it's not, because it's going to keep going forever. So because though we are restricted to only looking at one specific interval from a to b, there will be an absolute highest value in that interval, and there will be an absolute lowest value in the interval. So first of all, we want to note that we are on a closed interval. The next part is the way the question is worded. That's a D. I don't know what I was going for there, you guys. It's going to ask for the absolute max and min. Because think about it, if you're only restricted to looking at this set of points right here from A to B, you will have an absolute highest value in that interval, and you will have an absolute lowest. So you're going to see the word absolute today, which we haven't before. And you're going to see these intervals with the brackets, and they're going to mean they're closed. So this first part of this section is about the closed intervals. Now, let's talk about what we're looking for. Like I said, if it says, hey, can you find the absolute max on this interval? Isn't that just over all these points from A to B, which one is the highest? That's what we are asking. And the absolute min out of all these points, and there are an infinite number of points between A and B, right? Because it's continuous. I just want to know which one's the lowest. That seems like a lot of work. Remember, this is an infinite number of points. Should I just find a bunch of y values and just compare them all and see which one's the highest or lowest? I mean, of course that sounds silly because we're looking at a picture, but what if we weren't? What if I didn't know what it looked like? Would I just have to test multiple values in my interval, you know, until I thought, okay, well, this is probably the highest or this is probably the lowest? You guys, that would take forever. But looking at this picture, we can deduce some things that will help us do it faster. Notice that in this interval, we do have a critical point that is in our interval. Now, this critical point over here is not in our interval, so it's not having any effect on the answer of this particular problem. But notice that this critical point is the actual lowest y value in my interval. My absolute highest y value in my interval is actually this point at B. You guys, you're on an interval, the absolute min and max will always occur at one of two places. It will occur at a critical point, or it will occur at an endpoint. We have no need to test any other value other than the endpoints of my interval and any critical points that happen to lie within my interval. You guys, it's never going to be one of these because these points in between are always going to be in between either two endpoints, or they're going to be in between an endpoint and a critical point. So it narrows it down for us. Our list of y values that we need to find to see which one's the highest or lowest gets narrowed down to this list of critical points and endpoints. So in this picture, while we're here, you guys, this doesn't have a function, so I can't do it algebraically, but I can do it visually. Guys, what is the absolute max on this interval? Or we don't know what the value is, but I can say where it occurs. So you guys, as I look on this interval from A to B, the very highest point occurs at the second endpoint, at x equals b. And where's my absolute min? Well, it's occurring here at the critical point, which I didn't label, so I'll just say at x equals this particular critical point. Let's change our graph up a little bit before we start doing an algebra or an algebraic solution. So the graph is actually going to be pretty, well, I guess it's a lot different actually. Okay, so on this function, I want to know what's the absolute max from this point A to B. So here's x equals A. This is the point on the graph. Here's x equals B. So I can only look at these points here from A to B. Do you see any critical points happening in the interval from A to B? Well, no, you guys, because if I found critical points for this graph, they would occur here and here. They're not even in my interval. So I don't even have to consider them because they don't lie between A and B. What I do have to consider is only the endpoints. So in the absence of critical points, what's my choices? Well, it has to be one of the endpoints. Why do I know that this is not going to be one of my max or mins? Well, because it lies between the endpoints of A and B. You guys, it's lower than B and it's higher than A, so it's not going to be an absolute max or a min. So you guys, none of these values meet the criteria of being an absolute highest or lowest point. So if you don't have a critical point, can you see why your absolutes have to happen at the endpoints? If we did have a critical point here, oh, I lost my x-axis. Oh, wait, I don't even know where it was, guys. Okay. So you guys, let me dot in some hypotheticals here. If this function looked like this there, look, we would have a critical point, and it might be an answer that I had to test. What if this function kept going lower and then back up to b? Then it would have a critical point in the interval, which would end up being my lowest point. So you guys, critical points and endpoints are the only values that are going to make these absolutes happen. So I don't want you to think about any other value in your interval except for a, b, and any critical point that happens to fall between a and b. So I want you to keep this in mind as we do an algebraic problem. And the first thing I'm going to do is I'm going to lay out a list of steps. So when you are finding absolute, max, and min on a closed interval. So basically the interval with brackets on both sides. These are going to be your steps. Oh, hold on, I gotta check. Okay, so here's going to be your steps. Step 1, take the derivative. You guys, that is a basic step 1 in all of chapter 12, right? Take the derivative, just the first derivative, you guys. We don't need the second right now for this particular set of problems. I set the first derivative equal to 0. You guys, this is how I'm going to find critical points. Sorry. All right, so I'm going to find the critical points just like I did in 12.1, just like I did in 12.2. The only thing is I only have to consider a certain amount of my critical points. So in step 3, I find the critical points that actually are on my interval. So you need to take that time, take that step to look at each critical point that you find, and if it's not in the interval stated by the problem, then you don't have to consider it at all. You can just forget that it's there. But any critical points on your interval, you are going to have to consider for the next step. The next step is to test any critical point on your interval and also your 2 endpoints. Now, I say test them. The question is, where do I test them? Is this like a first derivative test situation? Do I want to know where things are positive or negative? Do I want to do the second derivative? No, guys, that's not going to help me at all. Let's look at our picture, and I really want you to understand the way we're testing these. So let's go back up to our first picture. And in this picture, basically we've done steps 1, 2, and 3 already. I found any critical points that lie within my interval, which was this one. Now I'm going to test these 2 endpoints and this critical point. But you guys, what do I want to know about them? You guys, all I want to know is what is the lowest y value on the graph and what is the highest y value. So I think all I need to do is just find the y values at those points and compare them. You guys, I don't care if the graph is moving down or moving up at that point, which means I don't care if the derivative is positive or negative. All I care about is what the actual function equals at each of these points. So where am I going to test these? I am going to test them in the original function. I'm just going to find their y values. So yes, I do have to take the derivative. I do have to find critical points, but that's not actually the point of this problem. It's not what gets you a solution. I find them so I know what values to test. Now that I know what values to test, I put them into the original function. I get a bunch of y values to go with these x values that I've tested. The highest y value on my list will be my absolute max, and the lowest y value on the list will be my absolute min. So now that I have a list of steps, which hopefully you've gotten written down, you definitely want to have this list of steps for this particular type of problem. We can work a problem. So remember, the algebraic, you're not going to have a picture. It's way too easy to pick out a high point and a low point from a picture, right? So we don't have pictures anymore. What we do have is f of x equals x to the fourth minus 18x squared plus 1. Here's our function. And I want to find the absolute max and min on the interval from -4 to +4. Remember, every time you have an interval, it is x values. So you know this means from x equals -4 to x equals +4. Okay, so step 1, find critical points. Basically, take first derivative and set it equal to 0. All right, so my first derivative here is going to be 4x cubed minus 36x. Did I call that step 2, set it equal to, yeah, so let's call this step 2, set it equal to 0. So say 0 equals 4x cubed minus 36x. Now, I know that the problems you've worked so far have usually started with a cubic, and then when you take the derivative, they're a squared function, and you do the factoring like reverse FOIL. This one's not like that, right? And it might seem more complicated because the derivative is a cubic function. And you might say, well, I don't know how to factor that. Well, there's a lot of different factoring methods. And honestly, the first one you always want to try is just pulling out the greatest common factor between your terms. You guys, these terms have a lot in common. So what I'm going to do to factor this is just, let's factor a 4x out of each of these terms. So what would that leave here? It would leave an x squared minus 9. So we're factored. What do I do when I factor and I have something set equal to 0? I set each factor equal to 0. So here I'm going to have 4x equals 0 and also x squared minus 9 equals 0. All right, so 4x equals 0, you get x equals 0. This is one of your critical points. If you add 9 on both sides here and get x squared equals 9, you do have to square root both sides of this one to get your x value. And be really careful. You'll miss a critical point if you don't take the plus or minus square root. When you square root 9, remember your answer is 3 or -3. So we have 3 critical points. Now, my next step needs to be look at your 3 critical points and decide which ones actually lie in your interval. So we have 0, 3, and -3. Does 0 lie between -4 and +4? Yes, it does. What about 3? Yes. What about -3? Also, you guys, all of our critical points are on the interval given, so that means I have to test all of them. Let's say you were working a problem and the -3 wasn't in your interval. Well, then you would just test 0 and 3. But you guys, on this one, all 3 of them are in the interval, so we have to test them all. So I guess this was step 3, right? Deciding which ones are on your interval. Now step 4, finally, we get to test these. So here's how I want you to set up step 4. I want you to make a list of all the values that you're testing. Remember, you do have to test critical points that are on your interval, but you also have to test the endpoint. So how many values is that? Well, we have the endpoint at -4, we have the 3 crit points, and we have the endpoint at 4. That's 5 values we have to test. I like to list them out from lowest to highest. So I do this, I'll do -4, what comes next? -3, then 0, then +3, and then +4. So I have a list set out, and I'm going to test each of these values. Remember where I'm testing them. I'm testing them in the original function. So what is our original function? You guys, it's right here. I'm going to put -4 in for all of those x's. So what's that going to look like? I'm going to have -4 to the 4th minus 18 times -4 squared, and then I'll have +1. So let's work this out. You guys, 4 to the 4th is 256. Now, this negative is being taken to the 4th power, which means it disappears, right? Because it's an even power. So I get positive 256 minus, well, you guys make sure that you square this before you multiply it by 18. So it is going to be positive 16 times 18. So you have, it'll be minus 288, and then we'll have +1. So you do that subtraction. I think what we get here is -31. So what have I found? You guys remember, I put it into the original function, which basically means I found a point on my graph where x equals -4 and the y value is -31. All right, let's put the -3 in. So f of -3, you guys, that's going to be -3 to the 4th minus 18 times -3 squared plus 1. So when we work this out, again, those negatives are going to go away because we're taking them to the 4th and then taking it squared. So we're going to have positive 81 minus, you guys, this is going to be 18 times 9, which is 162. And then we'll have +1. And you guys, that's going to leave you with -80. So what does that mean? It means that on my function, I have a point at -3, -80. All right. Sorry, we got test 0, which we know is the best thing to test, right? Because when you put a 0 in for all these x's, what are we going to be left with? Well, we're just going to be left with a 1, a positive 1. So what's that point look like? It looks like x equals 0, y equals 1. Now, I need to test +3. But you guys, I'm going to just use what I know about this type of function to make it easier. Guys, remember when I put -3 in? I fourthed it, I squared it, and those negatives turned into positive. So don't you think I'm going to get the exact same answer that I got above when I do 3 to the 4th minus 18 times 3 squared plus 1? Because those powers are going to take care of my negative anyway, I'm going to get the exact same value for 3 and for -3. And if you don't notice that, that's okay. You can still work it out. You're going to get that value one way or another, right? Sorry. So we have the point where x equals 3 and y, again, equals -80. Last one, putting a +4 in for all of these. You guys, I think I'm going to get the exact same thing I got when I put a -4 in, which is true. You guys, you're going to get -31 again. So that is a point where x equals 4, and again, y equals -31. Okay, so now what? I tested all my possible answers in the original function. Now it's time to classify which, and you'll only have an absolute max and an absolute min. So basically 2 out of these 5 values will be, you know, your answers. All 5 of them won't have a classification. So you guys, let's talk absolute max. How do I look at my list and decide which one it is? Remember, absolute max is just the highest y value on the interval. You guys, what's my highest y value that I just found? It's not actually very high, but it's positive 1. So my absolute max occurs at x equals 0. And if you need to know the value there, you already have it. It's 1. Let's find your absolute min. You guys, so now I need to find the absolute lowest value on my interval. It actually happens twice. If it happens more than once, that's okay. You can have 2 separate places where it occurs. Your absolute min occurs at x equals 3 and -3. But you guys, your y value there is -80 for both of those. So you can have 2 solutions, either for max or a min, if those 2 values give you the same y. But that's all there is to it, guys. We followed the steps, and that's what you're going to do on each of these problems, is follow these steps right here, making sure you're testing in the original function, which we did, and then after that, you're just comparing numbers. You guys, hopefully we can do greater than and less than, right? So this is what your closed interval absolute max and min questions are going to look like. We're not going to move on to the next part yet. So let me see if I can find us another example here. I guess I need to leave this here. I don't know if you've gotten it down yet. I'm going to leave that here then while I find us another example. Maybe just one more. Here's a good one. Let me check this one. Make sure it works the way I want it to work. And then I'll write it down for us. Okay. Okay, so next function. This one shouldn't be as long. But, you know, long example has more practice, right? So in this function, I've got f of x equals, I already forgot what it was, x cubed minus 3x plus 1. Okay, so this is my function. I want to find any absolute max and min on the closed interval from 0 to 2. So my interval's not as big on this one. So less area that I would possibly have to be testing. So what's my first step? Take the derivative. So I get 3x squared minus 3. And you guys, my second step is to set that derivative equal to 0. So you guys, this is a squared function, but notice I only have 2 terms. I don't have that middle x term like I usually do. So the factoring is going to be more simple here. So I'm going to add 3 on both sides and get 3 equals 3x squared. And we're just going to isolate the x squared term. So let's divide both by 3. And so I'll get 1 equals x squared. Be careful here, because when you do square root both sides, you're going to get x equals plus or minus 1. So you do have two critical points at +1 and at -1. Let's decide which one. I don't know why I wrote -3 there. Let's decide which one we have to deal with. You guys, is 1 in between 0 and 2? Yes. What about -1? Is this in our interval? It's not. So you guys, I don't even have to look at it. You guys, I have just thrown that out of my mind. All I'm concerned with is this one right here. Now, what do I do with that? You guys, this is where I test. But what do I test? You guys, I test the critical point that's in your interval, and you also test your endpoints. So I have 3 values to test. So let's put them in order. It'll be 0, 1, and 2. Where do I test them? You guys, I test them in the original function. So go back up to the original function and put 0 in for all the x's. So that's going to look like 0 cubed minus 3 times 0 plus 1. And I'm going to get a 1. So what did I find? I found that x equals 0 and y equals 1. Turn it down a little, sweetie. Let's test the 1. You guys, when you put a 1 into the function, I get 1 cubed minus 3 times 1 plus 1. So you guys, that's going to be 1 minus 3 is -2 plus 1 is -1. So what does that look like? It looks like I had an x of 1 and a y of -1. Let's try 2. You guys, you're going to get 2 cubed minus 3 times 2 plus 1. So 2 cubed is 8. So 8 minus 6 is 2 plus 1 is 3. So at this point, I have x equals 2, y equals 3. So out of these 3 values, we compare, right? So the absolute maximum value is going to be the highest y value. And make sure that when you're comparing, you are comparing the y values and not the x values. Obviously, the highest x value, you know, is easy to find. It's going to be at the bottom of your list, right? We are looking for y values. So the highest y value is this one, though. You guys, it's the 3. So the absolute max occurs at x equals 2, and the value there is 3. Your absolute min, again, the lowest y value. You guys, it's this one, right? The lowest value for y for us is -1. So the absolute min occurs at x equals +1, though. Remember, it occurs at the x value, and the y value there is -1. So that's really all there is to it, guys. Notice that one was a lot faster, but we did still do all the steps. We found critical points. We decided which ones to consider. And then we did consider that point and along with the endpoints, and we put them in the original function. I can't say that enough on this part because it's not what we're used to doing in this chapter. We're used to the first derivative test or now the second derivative test. This is the only time that we have an original function test. And then once you put them in there, remember you're just comparing which one's the greatest, which one's the least. So that is the first part of 12.3. You guys, like I said, I'm going to do the second part of 12.3 next time. And you guys, this week, we are staying in 12.3. So my goal on Friday is once I, show you how to do these things, we'll be ready for some actual application problems. So on Friday, my goal is just to have a day where I work through like word problems, basically, applications. And some of those will involve 12.1, 2, and 3. So it'll just kind of be a mixed bag. All these applications, we will decide together which method I have to use, and then we will use it, and it'll be really good practice. So But that's all I have for you today. Let me see if there's anything important I want to tell you guys. I'll be putting this homework up later. Definitely, you know, it doesn't have to be done today or anything because I'm not even going to be done with this section until Wednesday. It'll be due at the end of the week, but if you do want to start it, you know, if you want to do like this part of it, then, you know, by all means, you can get started on it once I get it up. And other than that, that's all I have for you. So I will just see you on Wednesday then.